Hello, Algebra 2. Here are the solutions in case you had trouble with any of the problems for 9.6. Luckily, it was not a very long assignment. So let's take a look. On the first one, you're supposed to write the function. So I'm going to start at the origin and treat this as one cycle. Since we started in the middle, I'm going to write this as a sine. I always like to figure out my vertical shift is 0. My amplitude, again, remember that goes to the high and the low. That looks like it is a distance of 3. And my period, the distance it takes me to complete one cycle, in this case it looks like it's 2 pi. So that means the b value, which is always 2 pi over 2 pi, is going to be 1. And our phase displacement, our phase shift, is none. So this only has really the one transformation, which is the amplitude. So it's your basic sine graph. Oh, wait a minute. I'm sorry. This is pi, not 2 pi. I said that wrong. So let me get rid of 2 pi divided by pi is a distance of 2. So we have the two transformations here. So we have nothing added. Your amplitude is 3. We're going to do it as a sine graph, and the b value is 2, and that would be your equation. Now let's look at number 14. Number 14, if I start at 0, which is always the easiest because then your d value, your phase shift is 0. So this is I'm going to do this as a cosine since it goes from high to high. My vertical shift again is 0. My amplitude, I'm trying to read my graph here, looks like it is an amplitude of 5. And my period is pi over 2. So we want to find the b value. That's going to be 2 pi divided by pi over 2. When you invert and multiply, that becomes 4. And our phase shift is 0. So this will be y equals 5 cosine 4x. And then this next one, well, you have choices, but I'm going to do it again starting at 0 because that makes it a little bit easier. Notice now I'm going low to low. So what that means is this is going to be a graph with a reflection. So my vertical shift still is 0. My amplitude is a positive 2. That's that distance to the high value, but I'm going to put an R here because we have to represent that it's reflected. My period is a distance of 4 to complete one cycle. That means my b value is 2 pi divided by 4, which simplifies to pi over 2. And our d value is 0 since we're starting at 0. So this will be y equals -2. That negative represents the reflection, cosine pi over 2x. Yeah. And if you look in your book, they have a phase shift where they started at 4. I'm not sure why. They didn't need to, but that's on them. Okay, this next one, now we have a new sinusoidal axis. So let's see, let's do this as starting at 0. That always makes it a little easier. So it's going to start here, it's going to end here. If we do it that way, it would be a sine graph, but a reflected sine graph. So our vertical shift, since sine starts on the sinusoidal, that's a -2. My amplitude, it looks like we're just going up 1 and down 1, so the amplitude will be 1. And my period, how long does it take me to end? I'm trying to figure out what some of these points are supposed to reference to. So this is 1, this is 2, this is 3. So it took me a distance of 2 to complete one cycle. That means that the b value is going to be 2 pi divided by 2, which is just pi. And then we're still starting at 0, so I don't have a phase shift. So y equals -2. We are reflected, so it's going to be minus sine pi x. All right, so there's the equations for those 4. Now let's get on to our modeling. One of the largest sewing machines in the world has a flywheel which turns as the machine sews that is 5 feet in diameter. So I'm just going to so we have something that is 5 feet in diameter. That tells me my amplitude is going to be half of that. So my amplitude will be 5/2. The highest point of the handle at the edge of the flywheel is 9 feet above the ground. So this is kind of like in the notes, I always like to do a graph first. It's just the way I work, sorry. So we're 9 feet off the ground, that's the low point. And so then a distance of 5 feet would put me up here at 9 plus 5 is 14. I can add, hello, that's 14. Let me write that better. Kind of mess that up a little. So that gives you that diameter of 5. Halfway between those is, this will be 11.5. I'm going to write it as a decimal. So 2.5, 2.5 feet up. And the lowest point is, oh wait a minute, the highest point of the handle at the edge of the flywheel is 9 feet above the ground. The lowest point is 4 feet. Sorry, I should have probably read the whole problem before I go on doing this. All right, let me start this over. The highest point is 9 feet above the ground. The lowest point is 4 feet. Okay, that makes sense. That's a distance of 5 for our amplitude, but 2.5 is going to put this at 6.5. All right, so now we're good. The wheel makes a complete turn every 2 seconds, so the period is 2 seconds, which means the b value will be 2 pi divided by 2, or just pi. And write a model for the height of the handle as a function of time, given that the handle is at its lowest point when t equals 0. So it means you're going to have a graph that looks like that. So low to low. So it's a reflected cosine graph because you're going low to low. So we know that our vertical shift, because that's our new sinusoidal, is at 6.5. So I'm going to have y equals 6.5 minus 2.5. That minus is your reflection, cosine pi x. Since there was no horizontal shift, I don't have any d value, and that would be your equation. All right, now let's do this next one. The Great Laxey, I don't know how to say that, wheel, located on the Isle of Man, is the largest working water wheel in the world. The highest point of a bucket on the wheel is 70.5 feet above the viewing platform, and the lowest point is 2 feet below the viewing platform. The wheel makes a complete turn every 24 seconds. Write a model for the height of the bucket as a function of time, given that the bucket is at its lowest point when 2 equals 0. So if I were to do kind of a little graph of what they're talking about, the lowest point is 2 feet below the platform. So we're going to let the axis here, the x-axis, be the viewing platform. So 2 feet below would be -2, and then this would be 70.5. So that gives me a total distance there of 72.5. So half of 72.5, if I divide that by 0.5, this is going to give us our amplitude. So I have to go to my handy dandy calculadora. 72.5 divided by half, or half of that, ooh, I did something wrong. I'm trying to take I should have multiplied. Sorry, not divide by half, multiply by a half. So 72.5 times a half is 36.25. Now, where does that put me? So that's the distance, that's our amplitude, the 36.25. So if I take 70.5 and subtract, I'm taking 70.5 and I'm subtracting 36.25, that's going to give me my new sinusoidal axis. So 36.25, this gives me 34.25. That's my sinusoidal. Now, they told us that the period is 24 seconds. That means the B value is going to be the 24 seconds divided, my brain kind of just went on a little holiday right there. So it's going to be 2 pi divided by those 24 seconds, or pi divided by 12. Okay, putting it all together. So you have a vertical shift of 34.25. You have an amplitude of 36.25. You have a period of 24 seconds, which means the B value is pi over 12. And again, we're going low to low at 0. So D, or the phase shift, is going to be 0, but this is going to be a reflected graph. Putting it all together, we know that Y equals, I'm going to run out of room, 34.25 minus, because it's reflection, it's going low to low, so it's going to look like that, minus 36.25, I have to shrink this up so I can fit it all in, cosine pi over 12. And really, if I'm going to do this correctly, instead of an x, what I should be saying is h of t, because we're talking about the height with respect to time, is this equation. Minus 36.25 cosine pi over 12t. That would be your equation. All right, well, I hope that helped.